Hi guys, Frankenstein here. So I want us to look at the Norton's theorem, routine I say. So they want us to solve the problem according to Norton's theorem, guys. So we must convert the circuit into Norton's theorem, but from those nodes, remember? So everything on the left hand side must be converted into R routine and I routine as well, right? So how can we do that? So first of all, we need to find our routine. Fine. So what we'll do is redraw that circuit there so we can solve. What am I going to say there? I'm going to say that the circuit will look something like that. But now remember, I want to draw the circuit which I'll be calculating the total resistance or the R routine. Actually, not the total resistance, but the Norton's resistance actually. So I'm going to replace any current source. So when you're doing that, you must replace current source with what? With an open circuit, and then replace a voltage source with a short circuit, and then you can then calculate your total, your not the total but your Norton's resistance. So I'm going to draw the circuit, redraw the circuit, so it's going to be something like that. A resistor there, and then we have that resistor there, and then those two nodes. And very important, by the way, guys, you remove the R load or the load or the place where you're referencing to. So the place we're referencing to is the right hand side. So on this portion, we remove what's on the right. Everything on the right will be removed, and then everything on the left will be remain as follows. And then looking at this one, we still have 6 ohms here, and we still have 3 ohms there. Yeah? And then what we need to understand is that these two resistors are in what? They are in parallel, agreed? Because they are connected onto common nodes, that node and that node there. So meaning that our R routine, not our total by the way guys, very important. Our R routine will be as follows, is equal to R1 multiplied by R2 divided by R1 plus R2. What is R1? R1 is 6 multiplied by 3 divided by 6 plus 3. And let's see what does that value give us, guys. Let's make sure. Our value there is 2. So we're getting 2 ohms as our Norton's resistance. So R Norton is equal to 2 ohms. Ne? And then what we need to do is replace everything back. Any current source or voltage source we removed, you must replace it back and calculate the current which will flow across that load section. So let's erase that circuit which we redrew. And now we must redraw the circuit which we has a voltage source, so that voltage there, that resistance there, and also here. Then that is a 3 ohm resistor, and is a 6 ohm resistor, that is R1 and that is R2, and we have this part here. Now when you are calculating the Norton's current, you will replace that section where there was the load resistor with a short circuit. Ne? Replace that section with a short circuit, by the way guys, very important. Now what you're going to do, you're going to try and find the current which will flow through, you're going to try and find the current which will flow through that wire which you've produced today, right? and that would be our Nortons current. Okay? So how are we going to do that? First of all, we need to calculate the total resistance in this thingy. So our total will be equal to 6 multiplied, oh sorry, not 6, but start from the start. So it will be R1 multiplied by R2 divided by R1 plus R2, right? So that should be 6 multiplied by 3 divided by sorry guys, by the way, we can't do that. Why can't we do that? Because now we have to understand that we have another wire here which is a short circuit, which has what? Has a resistance of 0 ohms, right? So meaning that when we analyze the circuit there, if the current will flow like this, and when it gets here, it has to split. But now remember the current wants the section of least resistance, right? So what you will do is understand that no current will flow in this resistor. All the current will flow this side. But now, for the sake of not changing the circuit, we will act for this certain level of understanding, or this level of Eng1, of electrical Eng1, we will take a wire as 0 ohms, which it has a resistance of 0, which will make this wire and this resistor in parallel, and then it will make this resistor and this resistor in what? Sorry, this resistor and the combination of the two in series. Agreed? So meaning that we will do that and say that R parallel is equal to 3 multiplied by 0 divided by 3 plus 0, and our resistance there should be 0. Therefore, R total will be equal to R parallel plus R1. Agreed? Therefore, R1 will be 6 plus 0, which our total resistance should be 6 ohms. And this makes sense because we've introduced a short circuit here, meaning we can actually cancel this resistor. Therefore, we only have one resistor in the circuit. Therefore, since we have our total resistance, we can actually find our total current, which will be the same current which will flow here, because we can actually delete this resistor there as if it doesn't exist, because it's not significant. It adds no value. No current will flow through it. So we'll find this is our total, by the way. Our I total is equal to V total divided by R total. Therefore, our total voltage is 9 divided by 6. The answer should be 1 point. That should be 3. Sorry, guys, not 1 point. No, that should be. There should be 1 point something actually. Sorry, guys. So our answer is 1.5. So we've got a current of 1.5 amps flowing there. Okay? Now let's redraw the circuit, because they said we should actually find Norton's equivalent circuit. So we must also draw Norton's equivalent circuit. So we know that I Norton, because the same current total which will flow here, or the same current which will flow here, and I said that the current which will flow here, it will be I Norton. So that's I Norton, by the way. So I Norton is 1.5 amps there. So we can remove every gibberish we have here. Every gibberish we had drawn here, we can remove it and get left with only two components there. So our next equivalent circuit for Arduino will be a current source, there, and then we're gonna have a resistor there, which would happen to be Norton's resistance, and then there will be that portion there which we had removed. So this will be R Norton, which happened to be 2 ohms, and then here it will be Norton's current, which happens to be 1.5 amps, and then on these two nodes we'll replace it with that resistor, which is our load, because we didn't touch it, by the way, guys. So this will be our R load. So just like that, we've converted this circuit into a simple circuit like that, which we'll be referencing to the R load. So yeah, guys, um, appreciate it for the opportunity to explain this to you guys. We'll meet in the next one, guys. Cheers.